Hello, wonderful CTY people. Here's a little video on area. So what area it is the number of squares inside of, or the number of squares that something can hold. So here, we either have 3 groups of 4 or 4 groups of 3. This rectangle has 12 squares inside it. And here it's both the length times the width and the base times the height, because those are the same thing. And sometimes that can be a little confusing because in a rectangle, the base and the height, the length and the width, those are the same things. But that's not true for other shapes. And only one of those rules applies in general. I tell my students that to get area, you're always multiplying 2 things that are at right angles. So this is not at a right angle. It doesn't make a little, it's not perpendicular. To find something that's perpendicular, I have to draw a line here. And then I could take this red rectangle here and put it over there. And I can see that the number of squares that this parallelogram takes up, if I move this one over to there, it's going to be the same exact area as this rectangle. So this parallelogram also is 12. And it's the base times the height. So this height of 3, is that always going to be true? If I put the height here, I can again take off that rectangle, that triangle, and put this triangle from the inside of this over there. And I get a rectangle that's 4 times 3. So it seems like the base times the height equals the area for a rectangle and for a parallelogram. Parallelogram. That both those things are true. They can literally cut off part of a parallelogram and make it into a rectangle, no matter how extreme the parallelogram is. If I have this one, I can take this entire shape cut it off and put it over here, and I still get 3 times 4. So the area of this, the rectangle is outlined in black, is the same as the area of the rectangle outlined in red, and it's going to be the base times the height. What about triangles? So if I had a rectangle, we now are firmly decided that 3 times 4 gives me 12. But how is the area of the triangle related to that? Getting tired of red. How would the area here be related to the rectangle? So I'm going to say it's exactly half. Hopefully it's believable because I cut it exactly in half. So it looks like it's 3 multiplied by 4. That's a multiplication sign. Divided by 2. 12 divided by 2 is 6. This is going to be exactly 6. Let's see if that's true. 1, 2, 3, 4. This together is 5. Those 2 together is 6. I think it's believable. So there's going to be 6 squares in there. So this is also 4. And the thing that's at a right angle is the 3. To get area, we're always multiplying right angles. If I take this blue triangle here, that's this one. So I can squeeze this into this rectangle that's going this way, which is 2 times 3. Well, 2 times 3 is 6. So it's still 4. It's half of 4 times 3. So this one's also 4 times 3. Is it the same area? It's not the same perimeter. If I add up these 3 sides and these 3 sides and these 3 sides, I don't get the same thing. But I am, I think, getting the same area. So here, if I took this rectangle here, that is going to be 12 altogether. But then I'm taking away, this is going to be half of 3 times 3. This ends up being 4.5 squares altogether. This one's 1.5 squares altogether. So I'm going to get 12 minus 1.5 plus 4.5, or 12 minus 6, there's going to be 6 squares left in here. So anytime I have a 4 this way and a 3 anywhere this way, and I make that into a triangle, the area of this blue triangle is going to be 6 because it's 4 multiplied by 3 divided by 2. Okay, what about the other thing that starts with T? Trapezoid, well known for trapezoids. So I want the thin marker, but we're going to be fine. So this is 4, this is 2, and we want to multiply things at right angles. So I want to take this. So that's 2 groups of 3, that's going to be 6. And if I put these two together, I'm going to get another group of 3. So I end up with 6 plus 3 equals 9. Let's see about this one. I've got 6 here, and this is going to be half of 6. So that's also 3. So that's 9. So here's the reason why, or here's my geometric explanation. If I take the measurement of this line here that goes right through the middle, it turns out that's going to be halfway through both of these. It's going to be the distance that's halfway between 2 and 4. What distance is halfway between 2 and 4? That's 3. I could draw a rectangle like that. So the area of that rectangle is going to be 3 times 3. That the length of this side is the median, literally, of 2 and 4. And the height is 3. The same thing happens here. That's 2, that's 4. The length of this, now you can see that that's 3. You can count that that's exactly 3 boxes. And it's 3 boxes up. So the area of this rectangle or square, that's 3 by 3, is equal to the parallelogram, because I could take this little triangle and put it there. So what it is, it's going to be the average of the 2 bases. That's a notation for one base plus the other base. We're going to take the average of them and multiply by the height. And that gives you the area of a trapezoid. That's something we probably will never use in this class. You might not see that till 4th, 5th, 6th grade, but I thought I'd put it in my little area video. So I hope that's helpful. See you later.